The next questions have to do with physics. Is buoyancy a force? Is weight a force?
Yeah.
For both?
100%. Yes.
Are forces. Okay.
Buoyancy is an effect of pressure, which is weight.
All right. Do you disagree with saying that buoyancy is a force?
Well, it's pressure, so yeah, it is a force.
The answer is yes or no. The question is buoyancy a force? The answer to that is yes or no. So what's your answer?
Because of pressure, yes.
The answer is yes. I will record it as yes. It's a verifiable fact that air pressure decreases with increased altitude. At what point does air pressure stop decreasing with increased altitude, and why?
I would say roughly around 100 kilometers. That's what it's stated. And why is because gases are formed from the earth, not from the sky.
I don't know. I've never measured it.
Well, you can say that too, but I'm just going along with the, globe model.
So your answer is
repeat
100
their story.
kilometers.
Roughly.
Okay.
That's just a rough
And
guess.
why?
Because that's where
Gases are formed from the earth was your answer. I don't think that actually answered the question that was asked.
carbon dioxide comes from trees, right?
Okay, the air pressure decreases with altitude.
Okay.
At what point, as in pressure, does that air pressure stop decreasing? Let me make sure that that's very clear. I'm specifically talking about the air pressure itself. When does it stop decreasing and why?
That's around 100 kilometers. The carbon line.
And what's the pressure there?
According to the heliocentric model.
And what is the pressure there?
Lesser than the ones below.
What is the pressure at the Kármán line at 100 kilometers? What is the air pressure?
We can Google it. Do you want a Google answer?
No, I just want you to tell me. It goes
how
down
would
to
we
a
know if we've
certain.
never measured it.
It goes down to a certain value, and then it stops going down anymore from there. So, what is that certain value?
All right, Google it, Don. Because no one here has measured any of that, so we're just going to have to.
The Google answer is 3.2 times 10 to the negative 2 exponent pascals, I believe, is PA.
Okay. What makes it stop decreasing there?
Because gases are coming from the earth, not from the sky.
Okay.
That's why.
All right.
They're formed from the earth. Carbon dioxide comes from plants, not from the sky.
What causes tides?
Well, you guys say the moon. That's what you guys say.
Yeah, do you
does
want
the
our
moon
answer or the answer they give us?
Yeah, you want
No, what the test is your knowledge of the globe model. So what causes tides?
The moon.
The moon. Just the moon?
Spooky gravity. And the shape of the earth, which would be a ball in your model, obviously.
How does the shape of the earth cause tides?
Its tilt has everything to do with its orbit.
Okay, you're about to
which
get wrecked.
Gravitational pull it's most affected by.
Okay, so I've got the moon, spooky gravity, and shape of the earth are what causes tides. Is that your
Amongst all the
answer?
other flat earth explanations that
Is that your
I'm sure
answer?
you're not looking for. Those are three variables absolutely in your model.
Okay. Name 3 ways that we can measure the radius of the earth ourselves.
The moon,
Well,
right?
according to Alberuni, you can just look at it, I think.
Yeah, pretty
The
much.
horizon.
Or
Okay,
use
so
sticks.
Alberuni is one.
Eratosthenes using sticks and shadows.
Hold on. Bob, I really want your audience to know that we're not saying these are how you can do it. And I hope you don't misrepresent us by saying that here's how you can do it.
No, I'm asking how you think how you think the globe says we can do it ourselves. So you've got Alberuni and you have Eratosthenes. The question
Alberuni wouldn't be us doing it ourselves.
The question would be 3. So what's your third way of doing it?
GPS. I don't know.
The moon phases.
How do the moon phases tell you?
Don, shut up, Don. What the hell?
Okay, well, I'm still waiting on your third answer. So what's the third answer? What is the third way that you can measure the radius yourself?
We could lie.
You're welcome to.
Yeah, that's what we would do. So there's 3 ways to measure the radius. Looking at a horizon and saying something, lying about it, and what's the other one?
So you've got
GPS.
the horizon.
We'll say GPS.
And how does
measuring
GPS?
measuring the angles of sunlight at 2 different cities at the same time. That's how they did it.
So that is shadows, and that's Eratosthenes, which you've already mentioned. So what's the third way you want to do it?
Oh, sorry.
What is the third way that you can measure it yourself? The only thing that I've heard so far is a lie. Is lying a measurement?
It's a measure of honesty, yeah.
Wow.
Okay, so not one of you?
The third way is computing it.
With
right?
what?
The third way is computing it.
With what? What are you using to compute it? Alberuni and Eratosthenes are also computations, so saying computing it doesn't add a third way. I need a third way before we move on.
All right. Yep. Nope.
Sorry, I took a call and I didn't hear what the question was again.
The question is, can you name 3 ways, different ways, that we ourselves can measure the radius of the Earth? And so far we have answers of Alberuni and Eratosthenes. Alberuni looks at the horizon, Eratosthenes looks at the shadows. So what's the third way that we can measure the radius of the Earth ourselves? Now, if you don't have a third way, if you don't know a third way, just say so, and we'll move on. That will be your answer, is that you don't know the third way. You don't know a third way.
Going once.
Okay, we'll move on to the next. You have 2 ways. You have 2 ways. You did mention 2 ways. You can't name a third, but that's okay. This isn't supposed to be an easy test. It's just a test of general knowledge of the globe. Okay, we'll move on. What is the formula for the circumference of a circle? What is the formula for the circumference of a circle? I heard 2 pi r. Does everybody agree with that?
Z.
Anybody disagree with 2 pi times the radius of the circle?
I think Don disagrees. Go ahead, Don.
I'm doing something else.
Okay, so nobody disagrees with that.
No, I'm talking about gases.
Well,
What?
I'm sorry you have gases, but the question was, what is the formula for the circumference of a circle? And the answer that we got was 2 pi r. Does everybody agree with that? I'm going to take that as a yes. If two bowling balls touch each other at one point, do they share a tangent?
Yes.
That's an affirmative.
Tangent point, if you will.
What is the difference between scientific convention and scientific consensus?
They're both stories agreed on.
Which is which?
Conventional science is just consensus at a different period of time, I'd say.
All right. The question was, let me rephrase it slightly for you. Compare and contrast scientific convention and scientific consensus.
They're both stories agreed on. They're pretty much one and the same for the most part.
So you say they're the same.
I would
Yeah,
say
they're based on beliefs.
Oh, sorry.
I would say consensus is when a bunch of scientists get together and say this is what's true. Convention is a bunch of people or anyone coming together saying for certain measurements and distances and volumes, we agree on this, so we all can agree to that. I guess that would be the best way to me.
Please clarify that last point a little bit. What are they agreeing on with volumes and distances?
So that way they can have a standard of value, so they can all have they agree on it, like a meter. You agree what a meter is, everybody agrees to that. Or agree what a liter is, everybody agrees to that.
Okay.
Consensus is what is made up, or what may be a cause and effect issue. One group of scientists has to be the consensus. One group of scientists say this is it. Another group of scientists say this is it. And the majority would be the...
Yeah, and who's this?
Paul.
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 Okay. So let's move on to the next question then. I've got your answer on that. Pluto is no longer a planet. Is that an example of scientific consensus or convention?
Consensus.
They're both the same thing. Convention and consensus they're the same thing. I don't know why he's trying to distinguish.
I don't know if I agree with that, though. I think in science, cause and effect, there's a consent. That's why I give an example. A group of scientists say the cause of global warming is X. Another group of scientists say, oh. The consensus would say, the majority would say the cause of global warming is X. But a measurement or a device is a convention, which means time. The way we measure time is a convention.
So
meter, inches.
What's the issue with Pluto? So what's the issue with Pluto? Is that a consensus issue or is that a convention issue?
It's a consensus issue.
Consensus issue.
Okay.
I would say conventions, just as a little side nugget. Conventions are more like what they agree upon, how they go about their work.
Why do you say it's a convention?
Standards of practice, sort of a thing. What?
Why do you say it's a convention rather? Why are you disagreeing?
No. I say that the Pluto thing is a consensus, but I was just clarifying the difference between consensus and convention.
All right. So let's move on to the next one. How do you measure the airspeed of a bird with a camera? How do you measure the airspeed of a bird with a camera? How do you measure the airspeed of a bird with a camera?
Parallax.
Did you say parallax? So no answer for that? Going once? Going twice?
Can you repeat the question? Let's go
Yes.
back.
How do you
My
measure?
guess would be
I'm repeating the question first. How do you measure the airspeed of a bird with a camera?
Distance and time.
Distance and time.
Yeah. Common sense, right?
Any other answers? Okay.
I would say it has something to do with the frame rate of the camera, but that's just a guess.
Frame rate
There's
of the
many
camera.
variables. Many variables.
It's an open-ended question. You can name anything that you want as long as you can measure the airspeed of a bird with a camera with it. What would you use the frame rate of the camera for?
To help you measure how far it went in the time that it went, the time that it traveled in whatever distance it went.
Okay, the time. All right. And you would then use the frame rate of the camera to measure time, and then you use the content of the image to measure distance based on where the bird is at any particular time. Would you agree with that? Is that your answer?
Sounds like my guess. Yep.
I mean, that's what I thought you were getting at. Now, correct me if I'm wrong.
No. That sounds like what I said.
All right. What is work in physics, and what is the effect of work on gas pressure?
Bob, somebody already answered that question. I don't know. Are you waiting for others to answer it, or
I didn't hear an answer. Did somebody answer the question?
Energy transfer.
Energy transfer.
Oh, work is okay. Work is a transfer of
Energy. Yes. Energy transfer.
Energy transfer.
I
Can
wouldn't
you
say
give an
transfer,
example of energy transfer so that I
pushing a block.
The
Well,
question was, you stated pushing a block. What are you doing when you push a block?
what are you doing when you pull a block?
What are you doing when you pull a block?
You're expending energy over a distance.
There you go.
Energy over a distance. Okay. And how does that affect gas pressure?
I know you're trying to go with that force word, but I know where we're going.
How does it affect gas pressure?
Well, gas pressure would be the change of matter, not energy. What is that? That doesn't affect gas. What does that have to do with gas pressure?
That's your answer. What does it have to do with gas pressure? Because that sounds very suspiciously like the question that I asked. What is the effect of work on gas pressure?
There is no effect on work. What work is being done? It's a change of matter.
Okay. All right. We'll move on to the next. Does an open-ended pipe contain pressurized gas? Does an open-ended pipe contain pressurized gas? Is an open pipe a container for pressurized gas?
Yes.
It is.
I need a clarifying question though. Is
Yeah,
it in a
okay.
pressurized? Is it in a pressurized system?
Then it would be yes. Great, good question, Paul.
Okay. The question specifies pressurized gas. Does that mean that the gas on the inside and the outside of the pipe are the same pressure?
No.
Yes, if they're in the same system.
That's the definition of pressurized gas?
Well,
Yeah,
wait a minute
gas will be
though.
pressing in the container, not outside of the container.
Wait a minute though. It's a moment by moment analysis though. You can have pressure. You can have a pressurized gas, and I open the lid. For a few moments, the pressure will be there, but over time, the pressure will equalize with the surrounding.
Equilibrium. They'll say, yeah.
So is your answer that it is a container for pressurized gas, or that it is not a container for pressurized gas? Can it contain pressurized gas?
For maybe a short amount of time, but over time it will dissipate.
But it will dissipate. So it's not like a gas cylinder is what you're saying, or a tire that has... If you put 40 pounds of pressure in a tire, in a gas cylinder, and in an open pipe, will they all contain that pressure?
No. Tire will contain it.
Tire will contain it.
Yes.
Yes, what?
The tire will contain it.
Yes, I agree.
Cylinder will too.
Cylinder will too. Will the open pipe contain it?
Not like a tire.
Okay, so is an open pipe a container for pressurized gas?
That's kind of different from how it was originally formed, the question. Because when
Shall
it's
I
formed like
replay
that,
the exact question again?
yeah, if you don't mind.
And what is the effect of work on gas pressure? Does an open-ended pipe contain pressurized gas? Does an open-ended pipe contain pressurized gas?
Do you not see the difference between that and is an open-ended pipe a container for pressurized gas?
Okay, what's the difference between contain and container? One is a verb, one is a noun. They both discuss the same concept, do they not?
So hold on. All right. So let me say something.
Does the open-ended pipe contain the pressure?
Hold on, Hammer.
Well, I'll clarify it because the like they were mentioning earlier, it depends on the situation. If it's in an open system, right, and like you originally formed the question, does it contain pressurized gas? Yes. If it's in a pressurized system that where's gas everywhere, then it's inside there too. But if you say
you're right, but you're wrong. What it does is it gives a resistance to the gas, so it builds up a resistance so you can get a reading for a certain amount. But if it's open, then that's not contained at all. The word open means non-contained. So if it's opened, it'll leak out.
But if it's in, what I'm saying is if there's already pressurized air around it, like there's going to be that pressurized air in there naturally, right? Versus the other way.
That is what's in contention, right? It's the container around that gas that's already around us.
Versus the other way.
Opened is open. You understand, right? Like if I open something, it has to be opened. It cannot be contained now. There is a release. If there is a release, there's a release.
I got you.
Okay, is it a container for gas or is it not a container for gas?
Yeah, hold on, guys. Just hold on, Bob. Hold on. Let me say something real quick, Bob. The way you asked it, you said, "Does it contain gas or is it a container for gas?" Which one are you saying?
I asked specifically, does it contain pressurized gas? What is the meaning of the word pressurized?
Yes, it does, because let's say I enclose myself in a box and then I have an open-ended pipe. The pressurized air in that box is going to be also inside that pipe.
All right, let's see if we can clarify this, because if you're having this much trouble with it, perhaps it's a poorly worded question. So let me rephrase it.
No.
By pressurized gas, I mean gas that is at a pressure higher than ambient pressure. So, for example, the 40 pounds of air that's in your tire. If I put 40 pounds of air in an open-ended pipe, would that pipe contain that pressurized gas?
No.
So the answer is no. Okay.
I would say yes for a short amount of time, and then it'll dissipate.
So I'm going to put a note in here that there is some consensus for briefly. And that is related to
My
And that
question
is
is this.
that is related to the fact that you said that the pipe would increase resistance to the outflow of the gas. So
Well,
as
my
a result,
question
there
is
will
this.
be a brief period of time that the gas pressure is
How do you
higher.
get? Here's the question: how do you get pressurized air from a tire into a pipe that's open-ended? Do you open up the tire and let that air out? What exactly do you mean by that question?
I think it's quite
Use
clear.
a shovel.
Yeah, use a shovel. Just pour it in. All right. So
Yeah.
let's go on to the next one. It's 5,400 nautical miles from the North Pole to any point on the equator. What is the circumference of the equator?
Hold on, let me create two.
Wow.
Check my calculator.
Get it 1/2 times the square root of the.
All right, Don, do you know the answer or not? Are you going to troll? What's the answer?
Just Google it. Easier. Just Google it.
No, the question is, there's a distance.
24,901 miles.
There is a distance from the North Pole to the equator. What is the circumference of the equator based on that distance?
What's the distance from the north to the south? Go ahead.
5,400 nautical miles.
And how do you get that?
And you're this is just a made up world, right? So you're saying from the
Nope.
north to the south.
Nope. That's the distance between the North Pole and the equator. What is the
Really?
circumference of the equator
Is
based
it
on
using
that distance?
straight lines or curved? Are these using straight lines or curved?
That is the
That's a
distance
good
from the
question,
North Pole
Don.
to the equator.
Curved lines are longer than straight lines.
Yes.
That is the distance across the surface of the Earth from the North
Right
Pole
here.
to the equator. So what is the circumference of the equator?
You'd have to demonstrate how you measured that.
No, I don't.
No. Okay, no. What he's explaining is you're going to take 5,400 and then multiply by 4, pretty much, because you're going from the north to the equator to the south to the equator back to the north. So it's going to be you're going to get a total. You should get a total at least of 26 or 21,600 nautical miles, I believe.
All right. How did you get that number?
Because I just told you, if you're saying from the north to the equator was 5,400 nautical miles,
Yes.
and you're saying it's a circle, then you got to do it 4 times. You got to go from the equator to the south to the equator, and the equator back up to the north.
What is the formula for the circumference of a circle?
Wasn't it pi r squared?
Was it?
Dude,
Pi r
I haven't
squared?
taken this for
2 pi
over 30 years, bro. Let me look it up.
If people aren't using that all the time, they're not going to know.
I never.
All right.
Let me see.
Well,
here.
I mean, that was an earlier question. The answer was
Yeah, that's what
already
I'm
given
saying.
for that.
Didn't say someone else
Says-
pi r squared.
No.
2 pi r.
2
Oh,
pi
that's
r
what-
was the answer given. What
The
is
circumference.
r if the distance from the North
So
Pole
half that
to the equator is 5,400 nautical miles?
Yeah. So what I would say is, it will be 21,600
How did you get that number?
because I multiplied it by 4.
So you multiplied 5,400 times 4. And with that, you got 21,600. Is that
Correct.
right? Okay.
Yeah.
That's your answer?
Yeah, hands down.
Okay. What is the formula for the circumference of a circle?
Let me see.
2 pi r.
Okay. So what's the r of that circle?
Six, 6, 6.
Okay, we'll move on. What is a nautical mile?
Measurement based on the Earth being a ball.
I need specifics. What is a nautical mile?
It's going to be based on, what is it, latitude or longitude?
You're the one taking the test. I'm giving it.
Which kind of presupposes one of the models, I'll say.
What is the definition of a nautical mile?
Wikipedia. The nautical mile is a unit of length used in air, marine, and space navigation for the definition of territorial waters. There you go.
I'm still waiting
Water.
for the definition of a nautical mile. What is the definition of a nautical mile? Not what it's used for.
just read
What
it.
is the definition of a nautical mile?
What does "is" mean?
Going once. Going
Distance
twice.
traveled through water.
Okay, nautical mile is 1852 meters, 6,076 feet, 1.151 statute miles, and 10 cable.
Okay, and what
What, a measurement
That's
of
the
distance used over the
distance.
ocean or in the space or
that's the
in air?
distance.
That's what a nautical
What
mile
is a nautical mile, though? A nautical
Distance
mile has a
traveled
very
through
specific.
water.
in the air.
Oversea.
Okay.
That's what I said earlier. That's what the Wikipedia said.
Right.
Right.
It is a unit of length used in air, marine, and
Okay.
space navigation. Holy crap.
All
I
right.
thought you covered that.
We'll go ahead and go on to the next one then.